Hi, I'm İlke and I'm going to present you my Physics 212 project. The aim of the project is to send information using a light source, in this case a laser module, and receive information using a detector, in this case a photoresistor. Both modules are connected to and controlled by an Arduino Uno board. Okay, now let me show how it all works. Here, this binary to decimal function converts a binary number into decimal, as the name suggests. Its function is crucial because the code later looks up the character from the Unicode table by the character's decimal representation, not the binary representation. This eliminates the need of knowing the exact bit length of the character, which solves a major compatibility problem. And the purpose of the next two functions are for the GUI elements. You will see windows and buttons and such. And here's the two-way converter between text and binary. It can be tuned to include from just basic Latin text, which is within 8 bits, to everything in the Unicode, including emojis, which is within the full 32 bits range. This version you see here is in the video is the version that works with a GUI and tuned to work with only 8 bits for this demonstration. The naked and the a little bit more easy to read version of the converter can be found in the final report appendices. Now let's run it. And here we type our text message to be sent. But before that, I want to point out that Arduino has only 2 kilobytes of dynamic memory, and this limits the message to be sent at most 2048 characters long. Yeah. And if you want to include the full 32-bit range to include emojis and such, then the character limit drops down to 512, which is pretty good, which is almost double the length Twitter allows today. I also tried numerous ways to compress the message, but considering how small the limit is, like 2 kilobytes, I couldn't figure out a compression algorithm which doesn't end up with a larger file than the original. For a compression algorithm to be useful, the file at hand should be substantially large. And now let's write, let's say, for the message, hi, I'm Dennis, and this is my PHYS 212 project. Click OK. And here, unfortunately, I also couldn't figure out a way to send the data from Python to Arduino automatically for this particular version of the Arduino board. So I have to here manually paste the bit string into the Arduino code. Here I pasted it, and let's upload it to the Arduino board and open the serial monitor to see the message. The ones and zeros you see here are coming from the photoresistor, actually. Let's wait for it to send all the message. And it's done. Let me copy it from here And now the Python asks the binary string. Let's paste it here. Click OK, and it shows the message without an error. And this is how it works. If you want to send another message, you can just click the new input and start all over again. And this is it. Thank you for listening. Here you can see the laser blinking while sending the information.